Are we live? We're live. Okay.
Okay, Ed, all because of you, we didn't have any of these podcasts for the last 2 months.
All because of me. Yes, yes, yes. Well, we are back. The rumors of our deaths were greatly exaggerated. So we are back with another context window podcast, and we will do our best to stick to the schedule because all of our many fans. All dozen of them have been like, "Hey, when are you guys doing
I,
doing?"
I, I agree with you. I agree with you. Between, that's why there are podcasters out there whose only sole job is to podcast. You and I, that's not the sole job. So things get in the way, which is no excuse, but it's an excuse in the sense that our schedules sometimes don't overlap or we get called into last minute sojourns. So that's why we've been a bit mm, lax, but we apologize to the audience.
Yes, yes. So anyway, we are back and here to do interesting conversation about the memory layer for agents, and we'll get into that in a little bit with guest, good friend of ours, Chris Latimer, who's got a very cool startup, Vectorize. .io that's been exploring the agentic memory space, and so we're going to have a really great conversation around that. This has been one of these areas where anybody who has been building agents, which is more and more of us, or for that matter, just interacting with many of the agentic tools, finds that the memory layer, how context is managed over multiple series of requests, actions, memory of previous requests, and what have you, becomes imperative. It makes the difference between a useful system and one that is just a dumb chatbot, if you will. And so we have a very long conversation around that. And but first, to kick things off, catching up a little bit on some of the interesting things that are going on. Probably from a starting point standpoint. Anant, you want to talk a little bit about some of the stuff Salesforce has been talking about?
Oh, yeah, yeah, of course, of course. So for those of you who missed it, Benioff came out and said that from next release onwards or whatever it was, Salesforce would be headless and would actually deliver a set of MCP servers and agentic servers and other things. And obviously then kind of pivoting and saying that our real value add is being a system of record and system of record for both the data as well as the processes, and they can be exposed and mixed and matched anywhere else. And obviously lots of people have been talking about the death of UX and agents don't need it. So it was very good to see kind of a leading enterprise SaaS player to kind of take that thing by the horns and say, we are actually going to do it.
Yeah, yeah. I think that this is a very important piece of from a product design in the agentic age piece, which I know a lot of the folks who follow this or folks, our colleagues, people who are thinking about how you build for delivering an application. What does it mean? So this is and it's a pretty significant transformation. This is sort of like right up there with in fact probably more profound than say 10 years ago when you were saying, okay, I got to deliver a mobile app. What does that
Yeah. Oh, of
mean
course.
for my business to be mobile? Or 10 years before that, saying, okay, delivering web applications, right? And we're old enough probably to remember desktop applications and client server and Windows and Mac and all of that. So this is this Headless 360 announcement to me, as a somebody, who has been a product manager and startup founder and so on. I'm always going and saying, what's the product? What does the product look like in this age? And obviously, Benioff is probably one of the key generational thinkers in this, in understanding, his whole, Salesforce existing, because he asked that question of how our enterprise application is going to be delivered, and said it's going to be via the cloud, which obviously, everybody today takes for granted, but was the first big bet on that. And so this idea of saying that an application now is going to be headless, and the things that we've talked about here, skills, MCP servers, these are the tools and distribution form factors that we're going to be building for. And so I think it's a huge validation for that idea. It's something that you and I have talked about.
Absolutely.
Yeah.
Absolutely. And it also means that it doesn't necessarily mean that UX kind of goes away, because in the end, what I'm also discovering is that kind of dashboards and others do help me get kind of a view of things. I'll probably talk a bit about it later on in some of how my workflow has changed. But the fact of the matter is that you don't have to own your UX, right, to actually deliver value. The value comes from the system of records, from the processes, from security, from authentication, and there's kind of a big decoupling, not just architectural decoupling, but actually business decoupling between owning the glass and owning the systems of record.
I think, which raised a good point. I think one of our future ones, we're actually gonna pull. I think we're gonna do a couple of these where we bring in some UX people, and I have one person in mind. They know who they are that we're gonna draft into this, because there is a whole, there is a whole science to building UX for use within agents. Both, a lot of people are saying, well, UX goes away, but it turns out with things like MCP apps and so on, that's not the case. And then there's also a whole discussion around, bring it back to sort of recent announcements, Claude Design, announced last week, and a whole conversation around that as to what does that mean. Obviously, Figma, mainstay in design, has also introduced some agentic capabilities, but it's raising a whole fascinating conversation about how is design built, and in fact, are AI tools becoming an important piece of that, not just in delivering designs to be used with AI, but actually how does AI help in building the design? And so I think that would be a great follow-on for us to do. But I know that's been one of the big topics.
Of course. And I feel that Dario and his team wake up every week and say, okay, what's the next thing they can throw on the wall?
Well, I think that's probably true. It's the marketing department goes and has probably a dartboard full of white collar professional job. In fact, what they probably do is just look at their org chart and figure out who are we going to automate today. But what they say is, ask not whom the bell tolls for.
Oh my God, was it Hemingway?
I think so. Don't ask me for the sources. I just know the memes.
No. Absolutely. There's just so much of discussion to have. And of course, Ed, somewhere, maybe without a guest or maybe with a guest, I want to talk about how your daily work or my daily work has changed. And actually, I'll just tell you this. I may have been slightly late to the party, but it has just completely changed in the last 4 weeks or so, when I just kind of went fully in and started to embrace it. So just be good discussion to have, right? Beyond meetings and outside meetings and everything else, the kind of work that we do that really makes us feel good about ourselves. I'm not saying meetings sometimes don't make us feel good about ourselves, but really what's changed, and it's just been absolutely profound for me.
Yeah, agreed. So a lot of good stuff. There was a bunch of other stuff in the news too that we won't get to. In fact, I understand
Security?
as we speak, I think that there's probably well, I know OpenAI is releasing yet another model, an image generation model that sounds exciting. So we'll, that may be, that we might carry that forward into
Yeah, we should.
but
I don't want to be one of the people who kind of reviews, oh, I tried both anti-gravity codex and Claude, and let me tell you which one is Claude code, and let me tell you which one is better. And you have to, it's all, a lot of these articles look like they are also AI generated. You're trying to get to the point.
exactly. Anyway, let's with that in mind, let's segue into our main topic. So
Yes.
Anant, you want to introduce it?
No, you have known Chris for a
Well,
bit longer because
I've known Chris for a while, but I wasn't going to do the full wind up on the pitch. But let me go ahead and do it. So I mentioned earlier, we have collectively been, learning how agents work, for the last 3 years, right? In terms of the various components, in terms of what are the constructs of where inference happens, in terms of generating these responses, where does information get retrieved for being able to go and be able to provide the data that makes it usable. But one of these key pieces, one of the things that started out by going and talking about what made ChatGPT work was this idea of being able to go and create a conversational interface that actually allowed you to operate within this essentially memory system that fed this.
it was mine. It was my memory.
Exactly.
It was my memory of my interactions with.
Yes. Yeah. And so there's a lot of terms for this: memory systems, context management, aspects of RAG, a whole bunch of things. And what we're doing as we roll forward is we're finding out basically what these requirements are. So our guest today, Chris Latimer, who's been somebody who's worked with both myself and Anant. We've known him for a long time. He was with us over at Apogee, the API management company, and then, of course, at Google, and then most recently working with me at DataStack, where actually he was really on the front lines of figuring out what RAG implementations looked like, and a few years ago went to create his own startup, Vectorize, where he's gone and thought deeply, along with his partner Chris Bartholomew, co-founder, who also was with us at DataStax, and really has gone and deeply explored the memory component of Agentic systems. And so we've got Chris on board. It's a reunion for us. It's awesome. But so very excited for that. Just a pleasure to see you again. But also, you're doing some really cool stuff.
Yeah, thanks, guys. It's exciting to be back and chat with you. I always never pass up an opportunity for us to catch up and share thoughts and ideas. And certainly, there's no shortage right now of cool things that are going on. But maybe to be good, just to give a little bit of background on how we got here and some of the evolutions that we've seen, if that sounds okay.
Yes, go for it. Let's jump right in.
Well, yeah, I mean, you remember back in like 23 and ChatGPT had just come out, and I think we all had that sort of magical like initial moment with these LLMs where it was like, wow, it's amazing what this thing just did. I asked it to make a blog post and like, wow, it's just there. Write an email and it's just there. I mean, once you read it, it was maybe not quite as exciting anymore, but it's still pretty magical. But really, really, really early on, we realized like, hold on a minute, these things know a lot, but they don't know everything. And it became apparent pretty quickly that there are blind spots in LLMs. And so we realized, okay, we've got all this knowledge. It knows generally about customer service. It doesn't know our customer service manual. It knows all about, how employees should behave, but it doesn't know our employee handbook. And so we realized, okay, we've got to build out this some way of getting knowledge from our organization, wherever it lives, into the LLM. And so we started, seeing all these new patterns pop up, right? We had sort of that first generation of RAG, and that's like Ed was saying, we were spending all of our time on that back in the day, and we figured out all the different ways. Ed and I saw basically every way not to build a RAG application, like every possible way you can misconfigure a vector index, and the data science team at the time did
my wife has a saying about RAG, which I think I've told this to you, Ed. RAG is a drag.
RAG is a drag. There you go. That should be
yes. We used to talk about RAG hell, which was like
RAG hell. Okay,
yes,
yeah. Right.
Yes. But the flip side piece of it, though, is my second favorite thing related to RAG, that also ends up being my least favorite thing, is the number of ways that people actually go and say, and so we're not doing RAG, and then they describe a system that is exactly RAG. Yes, yeah. So for people in the audience, by the way, who come in and are sending me LinkedIn messages, Kira, I want to tell you, Ed, all about this new thing we do that's beyond RAG. Please go back, read the RAG white paper again before you tell me that. But that's my own pet peeve as well.
What's really funny about this? So I just leaned into that a while back, and I started doing this talk called "RAG is Dead: Long Live Agent Memory," because what I realized that there's the white paper sense of RAG, which really it's like will never be dead. There's like no possible way it will be dead, because it just means my LLM has gaps in its knowledge.
Yes.
So some way, shape, or form, we must retrieve that knowledge from somewhere. It could be a file system, it could be a database, it could be a search API, and then we want the LLM to augment its generation. And so that pattern is sort of universal. And usually, if you sort of give somebody a dose of truth serum and you say, well, what exactly do you mean when you say like RAG is terrible? And usually it's like, well, I just threw a bunch of documents into my vector database and it didn't work very well.
Yes.
So therefore, RAG doesn't work. RAG's a bad thing. But I decided to stop fighting it, and I just
I know I've been on both sides of that one. It's just and I agree with you. And sorry, I didn't mean if I was raining on your one of your catchphrase. It wasn't. It's just it is one of those ones that I always love, which is like all that RAG said was that you've got parametric memory and non-parametric memory. And that's it. It did not actually. That the paper does refer to a vector database as one possible implementation of non-parametric.
The original Facebook paper, right?
Yeah. The one,
Yeah.
Original Meta paper.
Yep.
So go ahead. So then,
anyway, but that said, we've come a long way in terms of what that means, and it continuously evolves. Which brings us to, but I should say actually, Scott. So, Chris, that was part of your origin story. I mean, the company name itself, Vectorize.
Exactly. No.
You're right.
No, Chris, again, if I may just say so, when I was starting the company, we had a choice of either calling it GraphQL.io or stepzen.com. And I said the number of times I likely pivot is so large that I'm better off calling it Stepzen than GraphQL.
I know. Well, you're also at the mercy of like the good domain names that you can afford when you're starting a company. So, like I did like horse trading on Vectorize. Somebody wanted another. I had a domain called getbranch.com, and they wanted my Git branch. They had Vectorize.
Oh, you actually bartered it.
Oh, I have. Yeah. So it was like. It was the best we could hope for at the flea market of domain sales.
And if I remember correctly, you didn't have GraphQL, you had GraphCool.com, which wasn't very cool.
Oh, the story is better if I tell it like that, so that's okay.
Now, don't let the truth get in the way of a good story. That's exactly. Marketing 101. Yeah,
it certainly never hurts us here. So anyway, so that said, you're way beyond that. Like you've gone in where your thinking is. So don't let Anant and I hijack you on this stuff, because we are happy to get lost. That's what we do professionally, is get lost in the weeds.
Get lost? Yeah.
Yes.
No problem. I enjoy a good scenic tour on these things instead of a linear track. So it's actually great. But I think it's the same journey a lot of people go through. Just if you've tried to build agents in a production ready way and sort of a real world way, usually people have the same the same epiphanies where it says, okay, I put all my documents into a vector database. Great. This should do everything that I want. And then a user, gets access to the chat application and it kind of breaks. So like the number of times I've had somebody build a contract system where we load all the contracts in and they're very happy during the testing and they're like, oh, this is great. Like what clause do I have with this company? And it finds it. And then a user comes back and they're like, how many contracts expire next month? And it's like, oh, that's not a good semantic search use case. It's going to give you the top 5 things. And semantic search thinks that expired last month is similar to expired next month, and expired last year is similar to expires next month. And so, you're dealing with those kind of things. So people generally start to look at like, well, maybe I'll think about like Agentic RAG and I'll build a structured representation and I'll pull these things back and that, plug some gaps. And over time, I'd say like where the story leads is at least for me, I started to think about this and say, all of this is memory. There's a bunch of different requirements that fit within the world of memory. There's what I think of as semantic knowledge. And that's like, if, I don't remember exactly how, the orbitals and electrons like get excited, but I know where in my textbook from college I could go to find that and I could refresh my memory. That's kind of the semantic knowledge. I'm going to go look things up when I need it. And then you've got more of like the episodic memory, the conversation histories that happen. And then of course, kind of your working memory, especially as we start to get into this world of, agent harnesses and things like that. And to me, it's just, it feels like we're starting to get a more concrete view for the overall data needs for an agent. And to me, collectively, I think of all of those as agent memory, which is also nice because then I can say we don't do RAG, just like everybody else.
Yes.
So you're kind of bordering into now, you're not talking about collective consciousness and collective all of that stuff, the way psychologists talk about what is implanted in our brain when we are born and what is it that we learn along the way? Or are there some very good patterns with how humans and human memories work? Because some of the terms that you use are exactly the terms that you would use in context of human memory.
Yeah, well, and actually that's one of the things that we were talking about early on when we created this open source memory system called Hindsight, which has become very popular and lots of people are using it and has a amazing user community around it that are super passionate. I'm very excited about it. But when we were first kicking the idea around, we spent a lot of time talking about this, and we were saying, well, how does human memory work? And if we were the model we kept coming back to with an agent is we were thinking about if we weren't thinking of this as an agent, if we were just thinking about this as an employee, right? I could have a human project manager, I could have an AI project manager. How would we expect that project manager to get better over time? And if it's a human, you invite them to your meetings and they pick things up through the conversations, and eventually they learn, oh, okay, well, you guys use Linear for your ticket tracking, and you've got your database in Postgres, and you deploy to Vercel, and you deploy every Thursday, and you've got this release process that you go through. And we ask ourselves, well, what would that look like from an agent perspective? How could we have an agent learn that same way? And so we talk in our paper that we published with Virginia Tech about this idea of biomimetic memory structures, and how can we evolve the memory over time as new information comes in, so we're not just constantly going back to those raw memories, but we're forming kind of higher level thoughts and mental models of the world around the agent. And so, and that's constantly changing too. We're finding new ways and finding things that we thought would be a good idea and that don't work in practice, and so we fix them and we update them. But I think I still think that framework and that framing of the problem of how do we get our agents to learn is the key to what people are really looking for in memory.
Very interesting. Never thought about it like that. Okay.
Yeah.
So humans probably don't have a .md file for everything that they need to remember, and are not pushing into Glacier some MD files which are less important. But I guess there is some equivalence of concepts.
Yeah.
I mean, I think that's fair. The interesting thing is, as much as we go and say that's not the way people work, a lot of these things actually do have rough parallels, and I think that would be a whole other conversation. But clearly clearly the efficient, your memory layer systems, both from people or so on, are the same things, and even per your initial point of shared memory structures, both are a big deal as well, and both in these agentic systems and actually in the way that humans work too. So yes.
Well, you guys were talking at the top of the show about this idea of like the UX and how the UX is, where's that headed, and this world of certainly chat is going to be.
Can I crack up one? Where has it been beheaded, not headed? Okay, sorry. That's a
where's it beheaded? Okay,
right.
there. Okay, you get one pun a show, Anant, and you just used it.
Oh no, we don't. Anant does not.
Okay. You relax that rule. Okay.
Yeah.
Never mind. Have all the funds you need.
Yeah. That went out the window. We only were able to impose that in meetings back in the day, but no.
No, but this I see a bunch of parallels. Obviously, I'm sure everyone does, but between sort of this technological revolution that's happening now and previous ones, and so. I think the idea of the UX is interesting. I think the idea of the next big programming language being English is an interesting one. And I know, like this guy said, we've known each other for a long time, and I'm sure multiple times and over the years we've had a conversation that talks about this observation of infrastructure following applications,
yes.
Right? And sort of right, and that's how I think about memory as well right now in terms of. Go back in time to like the early NoSQL days, when it was like anyone's guess, like what was going to become sort of the next big, market there, the next big, vendors there. And the thing that, you had, everyone else was doing, these like table structures, and then you had Mongo that was doing JSON, and they kind of got lucky that, single page apps became this big thing.
Yeah.
And it was like everyone else said, oh, you want to use our database and you're using, Angular. Well, marshal all this data back and forth into a table back and forth. And Mongo kind of said, well, no, just hand me your JSON object and I'll stick it in and then I'll take it out and you'll be good to go. And so when I think about memory, I think about this sort of next generation of apps. And to me, it's like, well, the data structure, like people will talk about graph and vector, and of course those are in there, but it's really kind of English at the end of the day. It's like, I want to pull my memories back out as, as something that I can easily put into the prompt. And that's what we've tried to do. And, it's been kind of our guiding principle in hindsight is like, how do we take and condense down all these memories to parts that are easy to understand, that you can pass into an LLM where it's not sort of like disjointed chunks of docs, but it's actually like a more coherent narrative that you can feed the LLM. So like, for example, you see a lot of like questions that get asked, like, why did this happen? And you almost need like a time series. You need to be able to like break down the story. This happened and this happened and this happened. And therefore here's why, this happened. Why did the stock crash? Oh, well, this happened. This company, said they're going to cancel the contract, and then they reported it to Wall Street, and then it went down. And so I think about that a lot in terms of how we can, like, what is the infrastructure that's going to support these next generation apps that are coming out.
Yep. So you've actually, and so you've done a bunch of work around this in terms of, in terms of building, and so you've come up with an architecture around this.
Yeah.
And so what is some of the thinking that has driven, like, what can you step us through in terms of that?
Yeah. Well, one of the things that we had kind of observed through building our own agents is that unfortunately, there's no one size fits all in terms of just the best performing retrieval strategy. So some queries are well suited to vector. I do need a lookup, when, how many sick days do I get? And you want to query across your employee handbook. And that's a great semantic search question to get the right answer every single time. Some things are better for keywords. Some things are better for structured and graph queries, and some are better time series queries. So what we end up doing is we have 4 different representations of the data that we break your memories to. So you kind of feed in the raw LLM feed from all of the message history, and then we break it down. We pass it through a processor. It gives you back vector search. It gives you back dense and sparse, or keyword and semantic. We build out a graph structure so we can track the relationships between everything. And then if we find dates in there, we try to build out the time series of the data as well across those entities. So we end up with causal links and temporal links. And all of that sounds very complicated, but what we've done is we've built it down into a really simple recall API. So you just call a recall and you give us whatever query, typically whatever the LLM is asking for, or whatever your user is asking the LLM for. And we will go retrieve all those things in parallel, because we don't know in advance which one of those strategies will be best. And then we use something called a re-ranking model. And that's going to allow us to now have the most relevant things bubble up to the top. And then you give us a token budget. So you decide, how much you want to spend on that input tokens to the LLM. If you want to spend 5,000 tokens, and give us a budget of 5,000, we'll give you the best 5,000 tokens. If you want 1,000, the best 1,000, 10,000, the best 10,000. And it turns out it works out, very well in terms of getting back the most relevant memories for folks, and supporting I'd say a wider set of use cases that you might need in memory.
Yeah. Okay. That makes a ton of sense. So you're actually breaking it down into, and these are basically the 4 major types of retrieval, and then you're basically applying them to the different data sets, both from a conversational history as well as.
So you've got you're basically rank ordering within each data set, and then some weights across, and then you decide based on it which are the top 5,000 tokens that you want to pass.
That makes it.
Yeah.
And you touched on one of actually my favorite things that I often, for people that are building sort of custom RAG solutions, and just to expound on that, sort of this re-ranking approach is, for a lot of reasons, is incredibly underutilized, and actually is one of the sort of big wins in these types of systems, that just as a sort of pro tip for people that are trying to roll their own type systems that they just don't take advantage of. So I love that you built that into the architecture.
Yeah, and it does help a lot, even if you're just using, Cassandra as your vector database. And usually, again, the progression I've seen here with folks is, you start off and you think, well, I'm going to just get the top 5 values that come back, the top 5 most similar things that come back. And then you're like, well, why would I ever need to re-rank these? The LLM can handle the 5 just fine. And then you start to realize a bunch of your queries, like you cut it off too short. So now you really want to go to like the top 10, the top 20, the top 50. And when you start getting to that top 50, you start to realize like, oh, wait, I don't want to pass these in every time. Like that's a lot of tokens I'm burning through. And then that's where that re-ranking model becomes a godsend, because you just say, okay, let me re-rank this now by relevance, and then I can start cutting out all the things that are irrelevant. And I just have a tiny, I've got basically a penalty for whatever that model inference on the re-ranker takes, which usually is not a deal breaker for most people.
Yeah, no, that makes
awesome. Hey, you have a fascinating demo to show us.
Yeah.
I do.
Right? And I've got a couple of hard questions after that, but let's kind of take a break before.
Oh, I'm going to stretch out the demo as long as I can then.
Yes, absolutely. Make the guy climb the stairs slowly, even though he's kind of going outside.
Exactly. Well, one of the we built this demo for a couple of reasons. A, we thought it was fun and just more interesting for the audience, but the other thing is, when you look at a lot of agent memory, what they really are under the covers is simple RAG over the chat history. And so I wanted to kind of throw that entire model out and say, your agents are not just chatbots. Like a lot of times your agents are automating some task. And so I needed to find something that everybody could understand. And so we made this little video game like demo where I have an agent here. I'm going to start off by resetting my memory, and then I'll show you how it all comes together over in hindsight after this. But the idea is I have my agent, and I've given him basically no information other than the fact that his job is to deliver packages and a bunch of tools that he can use to do it. And so right now he's looking for Patricia Hughes. She works in building C, the HR department. So he needs to find his way all the way up here. He often gets lost on this his first attempt to get there, but okay, he made it there this time. And nothing else. So all he knows is there's tools in his job. And as he goes, we want our agent to learn. And the way that we do this inside of Hindsight is that each time we make these tools, we are sending the memories into the Hindsight system. And so we'll see here, our bank is here. And so this was the first pass. So he didn't do, all that much in this first attempt. He just sent a couple memories in. And like most agents, we're going to have more experiences the longer that our agent runs. And so we can give our agent like maybe a couple more deliveries that he can go off and do. And the idea is that as he's sending these memories in, there are certain things that we want the agent to learn. And in Hindsight, these are called mental models. Maybe I'll make it light mode, be a little easier for the audience to read. In Hindsight, these are called mental models. And the mental models that I want our agent to learn, in this case, are the building layout. So what offices are in what building, on what floor. The employee location. So where do the agents actually, where do the employees actually work in those buildings? And then how to get there. Because if you look back on he's going real fast now. If you look back on the building, sometimes I can cross this little bridge here. I don't have to go all the way down. So we want the agent to learn the optimal path. And so this is where I was saying, the interesting thing with Hindsight is that you have all these powerful data structures behind the scenes. You can use graph, you can use vector, you can use time series. But in this case, what I want my agent to learn is a small number of things. And if the agent has a very accurate representation of these things, it actually doesn't need all of the raw memories anymore. It can just leverage the things that it's learned. And so, and that's what you see here, even with just sort of the simple, few times through, our agents already learned, okay, there's, building C and the HR department is on the 4th floor. And it learned that Patricia Hughes is over here on building C on the 4th floor. So she works there. And so now if our little guy here is done, we should be able to go back to, say, like Patricia Hughes and start a delivery. And our agent should use this mental model now and go right up to exactly where she is without doing all of the random walk all over the building. And the same technique that we use here to train this agent on the optimal path and the building layouts and things like this, this can be applied to all sorts of different use cases. It can be your customer service AI agent where you want it to learn, how to respond properly to when people have troubleshooting requests or when they have questions about their bills. We've seen this in manufacturing space when a big airline engine manufacturer is trying to make sure that they're following all the quality management procedures and rules and regulations and automate audits and how audits should work and these type of things. So the same mechanism that's kind of packaged up into a fun little demo here can just as easily power all of your business critical agents that you're thinking about building for your company. And so hopefully that gives you an idea and a fairly entertaining form of Hindsight.
No, it's very, very cool, and of course extra appreciative of the 8-bit retro game vibes that always makes me feel right at home. But
you'll appreciate this, Ed, because I've got a Gen Z engineer who did a lot of the front end work, and I was like, we should make it like Donkey Kong. And he's like, oh, and he was talking about the like some 4th or 5th generation of Donkey Kong, and he's like, like the 3D graphics, like the one where he's like, we're running through the jungle, and then it's got a little guy next to him. It's like, no, like, don't you know the one where he just runs back and forth and has to jump over the barrels, and it's
you got like
no idea.
Blank stare. It was like barrels.
The Google browser dinosaur.
Yeah, exactly.
Yeah.
Awesome. No, this really actually brings to both in terms of kind of the demo, but also what's really happening in the back end with respect to kind of equivalent MD files. What exactly is it learning, right? Which just happens to be something that is then feedable into into the context. So may I ask you the hard question?
Yeah, please.
Okay, awesome. So as far as I know, as a human being, most of my memory is in my brain. And yes, I do consult notes and other external artifacts, especially as I'm getting older. But the fact of the matter is that a lot of things that I really do, I absorb and I make my mental model, my parameters better. So, is there an alternative universe where kind of the big models absorb all of the memory and all of the interactions, okay, and just make models better, perhaps in whatever shape, way, shape, or form, maybe some fine tuning or whatever it is, as opposed to an external system, and therefore the model by itself learns all the facts if the cost of fine tuning or whatever else is happening. So, what is this world going to be? There will always be external systems improving kind of commonly known facts, or will that get absorbed into these kind of large behemoths of models and their fine-tuned versions?
Well, we would have to. Somebody would need to invent a new architecture for that to work effectively. So never say never, right? I mean, somebody could come up with something new, but the way that transformer architectures work, it doesn't lend itself very well to being a solution for both the long-term memory as well as the kind of executive function. I mean, certainly, So I mean, I'll amend that slightly, because there's nothing in the models could do that today if the models had access to everything, right? If you as a company, let's take sort of like one by one the types of memory we have. So we have like the semantic memory, kind of the books on the bookshelf things. Those for sure, those today could easily be trained into a model. Most companies just don't want to let their IP go into obviously into a foundation model. So then the question is, can you fine tune around it? Well, you can. And then that leads into now a couple problems. Jailbreaking is a thing. Your ability to have control over access to that data becomes very scary if all you need is just the right prompt that gets discovered and it starts leaking out all your secrets. And so that's a bit scary. So then the question is like, well, could I change the architecture of the transformer model? Could I somehow have dynamic layers in my transformer model that don't require, all the same, gradient descent to get back to the outputs that I want? Not in the current architectures that I've seen. We talked about a technique like that when we were thinking about hindsight, and just the more we got into it, the more maybe we just weren't smart enough. Like maybe somebody smarter than us will figure it out someday and do it. But even if that happens on the semantic side, you still end up with this episodic memory and sort of the conversation history. What did we talk about? A model is a really, really expensive way. Like it would be like the world's most expensive database for that type of information. If you're going to go and sort of burn through GPUs to now train a model on that. And I think it might be technically possible, but it's almost like one of those things where, every, a couple of times a year, you hear the story that comes out where they're like, we've made this new type of battery and it lasts for, it's going to power your house for 2 years and it recharges in 5 minutes. And then you kind of dig into it and you're like, oh, but it costs $4 billion to make one of these things. So it's like, even if it becomes possible,
it's called the sun, huh?
It's called the sun. Yeah.
Yeah.
That's true. Yeah. Maybe they'll bottle it. That would be good.
Exactly. No, I mean,
Yeah.
I think it's a good point, and and I think it's a perennial question. I mean, obviously, I think for most of us, for all three of us, we usually come from the perspective that data and memory tend to be for either just sort of the dynamism, because your data has a life separate from the model life, and so then that makes sense, and you want to keep it in your database or whatever your storage system is. And then but there is that question, you get a lot less of it these days than 2 years back. You had people all the time who are like, oh, isn't fine tuning going to make this stuff go away? And I'd always be like, shut up. No, it's not. But yes, you had a lot of, well-credentialed people making that statement, and it was inaccurate, and it was inaccurate then, it's inaccurate now. But I
said a good point that,
yeah.
Look, token efficiency matters, right?
Yeah.
In the end, right? In the end, they're not free, and they're probably going to be one of the most expensive things, right?
I do think that sort of your semantic definitions, for example, are things that one can imagine that one would, in fact, it would be desirable to have some sort of form of continuous fine-tuning or LoRa or what have you, where that knowledge gets baked in at the model level. Like, you don't want to have your model fighting with the data, because the model will have its parametric knowledge and so on. And so in the cases of semantic definitions, that within my business, this refers to this, the definition of whatever it is, something related to product defects or customer policy or contractual policy or things like that, that represent standing definitions that are part of your semantic data, that no, yes, you can have it in your context graphs. Yes, you could have it encoded in your dynamic systems, but go ahead and do some form of fine tuning. And I do think that these types of systems would essentially will be what you use to deliver that fine-tuning data set. And then you'll get some optimization, and it will result in some token efficiency and some reduction of latency. And I think those things are all good. But they're not an either or. They're just making, and in fact, if you look at a lot of what makes, when people go and say, it's really interesting. I always go back to sort of where the future is unevenly distributed. If you want the most fully actualized agentic systems, they tend to be the coding assistants, because those are where you've got actual daily users in and out, right? Every day using these things. And so you go and see people going and saying, oh, this particular coding tool is better than this other coding tool. And there's a bunch of them. It's a very competitive space. We don't need to name names. But you actually go and break apart what makes one of them better than the other. What it tends to be is that they're better, that coding assistant A is better than coding assistant B, because it actually has been trained with better semantic knowledge about how to invoke certain tools. Because most of the action in these coding is around the tools. And so that's an example. What in the business analog, if I'm in a tax domain, knowing this piece versus this piece, and having that fine-tuned in the model will make that model slightly better.
But still, there's still a large space that doesn't make sense to get.
Oh, absolutely. The actual data itself, there's going to be dynamic. That's going to be in your data set. So that's my perspective in reaction to sort of, Chris, to your point. Like, at least in the domain that I live in of primarily, data agents, that's been sort of where my mental model has been going around these things. Is, yeah, there might be fine tuning that lets the model's parametric knowledge be more adept at understanding and interacting with the external data sets it's interacting with, just in the same way that in the coding assistant world, a code assistant that knows how to better use whatever Git, for example, right? These days, a tremendous amount of fine-tuning goes into making, these models be very adept at how to use various Git commands, just by way of an example. That translates into people sitting around and saying, oh, I like this one rather than this one.
I get it.
Yeah, and to me, that's a place where memory has a lot of potential. Is your foundation models, just like they had knowledge gaps on all of your semantic knowledge. they also have knowledge gaps on how to invoke your tools in your world and how you want your AI employees and agents to operate. And so this is a similar way of taking that same learning, that reinforcement learning feedback loop that we've built to say, my agents is going to make mistakes sometimes. It's going to invoke tools the wrong way, just like we saw with that demo agent, right? It went left instead of right. It went used the tools incorrectly to get to the first delivery. But once we've given it the ability to understand now, how should I invoke these tools to solve a specific task, it gets better and better. And to me, that's really like the biggest potential for memory and where it has the opportunity to add the biggest value. It's not so much just like, hey, who can search across these docs the best, but how can you actually make my agents better so I don't, as the AI engineer, have to go in and like, my agent messed up, let me go try to prompt engineer my way out of this.
Yeah.
Awesome. One question, final question from me, and then Ed, as always, will have the last word. So clearly you're making some bets about not just where the world is, but where the world is going. And probably there are people in Silicon Valley who are making a different bet, right? So if you think about it and say, where do you think people are wrong in terms of where they think the world is going? Can you give an example of that?
Well, I think, and I could just be spectacularly wrong on this, but I think all of the fear around AI.
What is that saying?
Huh?
It's what is hard to predict, especially about the future or something like that. Okay, go ahead.
Yeah. Well, yes. Well, I'm even worse than most people on it. But if you would have asked me when Uber was coming out, I would have said Uber sounds like the stupidest idea I've ever heard of. Like, why would this thing would never work? And there are other examples, but no, to me, it's like when I look at sort of the fear of AI and the level of paranoia that people have around AI kind of taking all the jobs and things like this. I just look at it and say, I've never worked anywhere, including today, including now, and sort of like the AI era we're in, where our problem is that we don't have enough work to do. Where like we're just out of things to do. Like we're all leaving at noon because the work is all done. And to me, it just feels like the idea that we'll have increasing numbers of agents and those agents will handle all the work is probably wrong. The world where the agents handle a lot of the work and we can just get more done is, at least the optimist in me thinks that that's where we're headed.
I absolutely agree with you. There's no, at least from a software engineering side, there's no developer who's sitting around and saying, give me more work. They're all saying, man, here's a bloody backlog that I can't get to.
Right.
No, I think that's...
And we were seeing it with apps, right? Like the apps are just better. Like MVPs are way better. Like I think everything's just going to be way better.
Well, yes, we'll have a conversation on that.
Sorry,
Ed.
No, I definitely think so. Well, I think you asked the good question, because there's got to be a anytime you're making a bet, there has to be a counter bet, somebody who's betting against it. So I do think that's I do think that's an important piece of the question of what Anant was saying. Like, you're making a bunch of big bets that agents are going to be built this way, that memory is going to be a piece of it, that people are going to be building these systems, and so on. I guess, what is the counter bet? The counter bet is that memory is going to be continuously, I don't know what, probably owned by the model provider. It might be the counter bet.
Yeah, I mean, to me, the thing that's like, what would make this entire memory market disappear overnight? And it feels like if you had some breakthrough, right? So it's like, if I could throw everything into the context window, and today I kind of can, and models do an okay job with it, but it's very, very expensive, and model providers have to deal with all of their, their high cost. Like they're not, they're still struggling to figure out how to, profitably, sell AI at scale. But if there was some breakthrough, right? If there was some breakthrough where you said, I'm going to get 10x better than Gemini 3 Pro at handling a billion contexts in a context window. and my efficiency of my chips is going to be so good that I can sell them to you at 2 cents per million input and 5 cents per million output, then it becomes a matter of like, well, then I would throw everything into the context window, assuming that like I'm happy with the privacy, data protections and things, except for when I have like latency requirements, except when I have to worry about sort of like the data transfer. But if there's no real incentive, if I don't get significantly better results by getting those 5,000 most optimized tokens, then like why would I bother? It's easier to do it the other way. Now, fortunately for me, anyway, that requires a number of like big breakthroughs that all come together in terms of everything from semiconductor.
Yeah, you went from $25 per million output tokens to 5 cents.
Well, it's true, but I almost feel that it's sort of the 640K is enough for everybody thing, because I've been hearing this statement about context windows, again from very well credentialed people, 4 years now, right? Like, oh, when context windows were 4K or 16K or 32K, or we've got context windows now at 1 million tokens, right? And then it's still, we're still not at the point where from a practical system, you go and say, throw everything in the context window and let the model sort it out. And honestly, we're way beyond where, again, all the smartest people in the room said was going to be the context window tipping point. And there we get to do the callback to the podcast name. Like, we're way beyond where people said it would be when suddenly these systems, when memory systems or RAG systems or everything else wouldn't matter anymore. Like, way beyond that. Like, at 1 million tokens, if I could go back in time and go and be in that room with various folks, VCs, and so on, where they were like, no, the context window is going to be this big next year, and hence we won't need databases anymore. And it's like, we're at this big and counting, and like no slowdown on needing memory systems and needing approaches to feed the context. Like, context curation, context management is going to be continues to be as big as it ever was.
Yeah, that one was always funny, and I've always referred to that as like the collective amnesia about how data retrieval works, because it's like, it's like, just because you bought a computer with a really big hard drive doesn't mean like every time you go to Google Drive you want them to dump every single file down to your machine in real time. It's like these things have real trade-offs. Like, that doesn't make any sense, and if that doesn't make sense, why would it make sense to always shove everything into the context window? But I know you guys are trying to wrap up, and anyway,
we'll take it from there. But Chris, great to have you on this, and just like old times. I wish you'd never left, but it sounds like you're having a blast with this new stuff. And doing some very cool stuff. So we're excited.
The name of his company going forward will be memorize.io, not vectorize.io.
Exactly. Exactly.
I will make an announcement if we change the name. It'll be hindsight something if we do, but for now it's vectorized, not to confuse the market. Yeah.
Yes.
Okay. Awesome. Thank you, Chris, so much.
Thank you.
Okay. Oh, that was
fun. That was great.
That's what we miss. Ed, stop being so busy.
Yes.
Spend time with me.
Yeah.
Let's do more podcasts.
More podcasts. Well, certainly, I think our goal, as we do more of these podcasts, is really to try to get to the practitioners, the people who are out there building cool things. So we are going to be talking to more folks at startups. We are going to be talking to folks who are actually walking the walk in terms of building these types of systems. So we have a great lineup of people, and of course that does extensively include folks in our network who, to the best I can determine, are the entirety of our audience. So feel free to.
Well, not bad, because at least my LinkedIn network is 4,000, and if yours is 4,000 and only 200 are in common, right? when we have 7,800 people. Okay.
It's true.
People.
That's true.
Okay. Hey, absolutely fantastic. I really miss doing this with you, Ed, and we'll do it again. And next week we'll rotate back into data, and we'll next time, and we'll have a chance to talk to Jun Rao, who I know really, really well. He was with me at IBM, and then he joined LinkedIn, and then he spun Kafka off and did Confluent, and now he's part of IBM again, with IBM acquiring Confluent. So we'll have a great discussion on the role of streaming and other things in the world of AI.
Yes.
And so that's what we're looking forward to.
Good. Well, thanks everybody for tuning in. Hopefully, and for those of you who are watching it on the replay, but we're excited to get this back into gear again, and thanks to Michelle and Hannah, Milan getting it all set up, but she's on vacation this week, so hopefully Milan is having a good vacation. But we're excited to be doing these.
I'm halfway through, maybe 1/3 of the way through. If anybody builds it, everybody will die. So it'll be a very good conversation to have.
So that one will be good in the future.
Yes,
too.
you better start spending your money. It's only $15 on Kindle. So
yes. So that one again, all the more incentive for us to have more podcasts before it gets built, because apparently we all have a shelf life now with unless our AI overlords are enjoying our
but according to them, there's no chance of that at all. Okay.
Exactly.
Awesome. Yeah.